For a year, Gemini has been the guy in the track jacket. He stood right outside the heavy boxing ring. He just watched ChatGPT and Claude trade heavy, exhausting blows.
Right. They kept dropping new models every single month. It felt like a relentless heavyweight title match.
Exactly. And then other contenders suddenly jumped in too.
Yeah, models like Pimi and Quinn threw wild punches. They completely messed up the global leaderboards constantly.
Meanwhile, Gemini just looked like that one hesitant friend.
The friend who claims they just haven't fought yet.
Right. Of course, nobody in the crowd really believed him. But now, Gemini 3.7 Flash just stepped over the ropes?
Beat.
Welcome to the deep dive.
We have a really exciting roadmap for you today. We are exploring Google's brand new Gemini 3.7 Flash model.
Finally.
Yeah, finally. We are going to unpack its incredible raw generation speed. We will also examine its surprisingly halved price tag.
Which is a huge deal.
Absolutely. And finally, we will test it inside the newly released DeepSeek Harness. We really want to see if it actually changes how you code.
Because this is not just another basic model update release.
No, it is not.
It is about fundamentally changing your entire developer workflow. But to understand why this specific model actually matters, we have to look at the raw numbers first.
Yeah, we must check the specs before hitting the track.
So Google kept the same fast direction for this Flash lineup?
They did, but this version focuses heavily on practical coding workflows.
Right.
The clearest upgrade here is definitely in software engineering. Let's examine the Frontier Code 1.1 main benchmark results first.
Okay.
Gemini 3.7 hit 43.6% on that specific test.
And what was the previous score for context?
That is up from 34.4% for 3.6 Flash.
Wow, that is almost a 10% absolute performance gain.
Yeah, it is huge.
In the AI space, that is a massive leap. It means the model solves 1 in 10 more problems perfectly.
Exactly.
It ultimately means fewer frustrating software bugs for you.
It even scored slightly higher than Claude Sonnet 5 there, and it easily beat GPT 5.6 Terra in Google's own comparisons.
But short bursts of coding are actually quite easy.
Mm-hmm.
The real nightmare is when an AI loses the plot entirely. How does it hold up when the task drags on?
Well, that brings us to the Deep SWE v1.1 benchmark test.
Right.
This measures an AI's ability to handle long workflows. Gemini 3.7 reached an incredibly impressive 65.3% score here.
And the previous version?
It only hit 48.6% on this exact same test.
That shows a massive improvement in holding a coherent thought.
Yeah, it really does.
It doesn't lose the thread halfway through a complex task.
Yeah.
Because refactoring an entire code base requires maintaining intense focus.
Absolutely.
This model clearly proves it can handle that heavy burden.
Web development follows that exact same positive growth pattern, too. Gemini 3.7 reached a highly competitive ranking of 1588 ELO.
Okay.
This was officially recorded on the Code Arena platform. That is actually the highest score among all the charted models.
But a smart model is totally useless if it bankrupts you.
Oh, for sure.
Good benchmark scores are really just pure potential energy. Pricing matters immensely when you run these models constantly.
Yeah, and the cost drop here is actually very aggressive today. It starts at 75 cents per million input tokens, and it is $3.75 for output tokens.
Wow.
Google says this is half the original launch price.
It is like finding a high-performance sports car engine. But you get it for the price of an economy compact. Beat. It completely changes the math on running it daily. Does this cheaper cost matter more than raw intellect here?
Well, for daily high-volume tasks, cost efficiency absolutely beats marginal genius.
Right.
You want something that is smart enough, but mostly cheap. I mean, imagine running an autonomous agent hundreds of times a day.
Yeah, the API bills stack up fast.
Exactly. You simply can't afford top-tier models for every single step.
But cheaper speed wins if it's smart enough.
Exactly. That is when a model becomes truly useful.
Good benchmark scores and low costs are just potential energy. We need to see how this translates to kinetic energy. We really need to look at the actual waiting time for you, 2-sec silence. Because raw processing speed sounds very impressive on paper.
Right.
But one benchmark number doesn't show the real human feeling.
Let's start with the pure text generation speed first. Artificial analysis tracked this specific metric very closely indeed.
Okay.
Gemini 3.7 running at high reasoning generates incredibly fast. It hits around 340 output tokens per second constantly.
Let's quickly define tokens per second for a moment. It is the speed of spitting out word chunks.
Yeah, and 340 is a massive number in daily practice. That is nearly 3 times faster than its direct rivals.
Really?
Yeah, it beats GPT 5.6 Tera and GLM 5.2 in the exact same test.
That number makes Gemini 3.7 stand out right away.
Absolutely.
But raw generation speed is still only one small part.
Right, you must look at the time to finish the task. Artificial analysis measured an average time per task too.
What was it?
The average task time is now just 1.7 minutes.
Wow.
And that is with the model running at high reasoning mode.
The high output speed brings that total time way down.
Yeah.
That 1.7-minute number is very easy to comprehend.
Whoa. I mean, imagine a standard 14-second wait for a chatbot. Imagine that wait dropping down to just 2 seconds.
That is totally game-changing.
It is. Users don't really need to know the exact token speed. They just see the complex answer appear almost instantly.
You stop watching those 3 dots spin endlessly on screen.
Exactly.
Your psychological flow state remains entirely unbroken while working. Because when you wait 14 seconds, you often check your phone.
Oh, every single time.
You entirely lose your delicate train of thought. 2 seconds keeps your brain completely locked in.
It really does.
But benchmarks usually happen in a very clean, sterile setup.
Yeah.
Real coding agents have a lot more messy work.
Right. Mahal Mohan ran a very complex security review test. It was a real software project with many files involved.
Okay.
Gemini 3.7 needed time at the start just to read. It had to use several tools to analyze the project.
So it couldn't just start typing instantly.
No, it had to think. But even with that extra work, the total run was fast. It's finished in around 2 minutes and 38 seconds.
That is still incredibly quick.
Yeah, and the counter went through roughly 90,000 tokens total.
Does this blazing generation speed mean it skips thinking time?
No, the model still has to pause for tool calls. It must physically stop and read the context carefully.
Right.
But the actual text output generation is basically instant.
Right. Tools take time, but generation is lightning.
There is one more crucial efficiency metric to mention here. SteveVibe ran a direct comparison test with 3.6 Flash.
Okay.
Gemini 3.7 actually used about 20% fewer tokens.
So it is fundamentally faster, cheaper, and far more concise.
Exactly.
It gets straight to the point without wasting any words. That is why this specific speed matters outside of simple benchmarks. When an AI talks to another AI, pleasantries waste compute. By being concise, it saves money on every single tool call loop.
It flawlessly combines shorter task times and faster tool workflows. Flash makes much more sense for complex agent workflows now. Sponsor.
Speed is completely useless without proper, reliable control.
Oh, 100%.
A fast car still needs a steering wheel and dashboard. To actually harness 340 tokens a second, you need deep visibility.
Yeah, you do.
You need a clear dashboard to see what the AI does.
Yeah.
Enter the newly released DeepSeek Harness framework.
DeepSeek just dropped DeepSeek Harness version 0.1 for developers.
Nice.
It is a developer preview, but it is an official release. It is a plug-and-play harness for building highly functional agents.
Let's clarify what agent workflows actually mean today. It means AI doing multi-step tasks on its own.
Exactly. It is built around a very simple, elegant idea. Almost every part of it works perfectly like a plugin. You don't have to do everything inside a dark terminal. You just type a simple terminal command to start it.
The npx command, right?
Yeah. It immediately opens a clean browser interface for you.
You aren't just staring at a scrolling command line anymore.
Yeah. No, not at all.
You get a full visual workspace to manage things effectively.
Once it is running, you choose your active coding workspace. The harness reads your project files for immediate local context.
Okay, that is super helpful.
You can also choose different operational modes for the working agent. There is standard, code, minimal, and creator mode available.
You match the specific setup to your exact current tasks.
Yeah.
You don't have to rebuild the entire setup every time.
No, you can easily change plugins and agent presets too.
What kind of metrics does this visual dashboard actually show you?
You get deep real-time metrics while the agent is running. You watch the tokens per second live on the screen.
Okay.
You see the exact time to the first generated token. You also track the cache hit rate continuously during execution.
Let's define a cache hit for clarity here. It means reusing saved memory to go faster.
Yeah, but the absolute best feature is the trajectory view.
Oh, tell me about that.
It shows exactly how the agent moves through the task. It details every single tool call the autonomous agent makes.
Right.
It displays the exact context used during the entire workflow.
I still wrestle with prompt draft myself, honestly. beat. It is deeply frustrating when a model forgets its original goal.
Oh, I know the feeling.
It starts building a calculator and ends up writing poetry.
Exactly.
Seeing the actual trajectory on screen is a total lifesaver. Why do we need to watch its trajectory, though? Especially if it eventually gets the right answer anyway.
Well, watching the trajectory helps you debug the underlying agent mechanics.
Okay.
You see exactly why an agent went completely off track. You understand why it suddenly slowed down midway through.
Right.
You simply can't fix a problem if you can't see the steps.
Got it. Visibility helps us fix bad behavior. Now we have the ultimate high-speed engine totally ready.
We do.
We also have the ultimate dashboard to monitor it closely. What happens when we put them together for a real test? 2-sec silence.
First, you have to connect Gemini 3.7 inside the harness. You do this easily using an OpenRouter API key.
Okay, so a standard integration.
Yeah. Inside the harness, you navigate to the Settings menu tab. You click on Models, then you select Add Provider.
Simple enough.
Select OpenRouter and simply paste your secret key to save it. Then you just select Gemini 3.7 from the drop-down menu.
So you are running Google's models securely in DeepSeek's environment.
Right, and watching all those critical performance metrics live. Steve Eich ran a truly fascinating test with this exact setup.
What did he build?
He asked Gemini 3.7 to build a 3D Rubik's Cube.
Oh, wow.
It was a heavy coding task requiring many distinct steps. The complex task finished in exactly 27 total minutes.
Okay.
It went through 52 separate discrete steps to build it. It ran at about 120 tokens per second overall.
Does that drop to 120 tokens per second mean the initial benchmark was misleading?
Not exactly. Benchmarks strictly measure pure text streaming speed.
Okay, just raw output.
Yeah. That is just generating one long continuous text answer quickly. Complex agent tasks require stopping to execute external coding tools.
Right.
The model has to think carefully between each discrete step.
Makes sense. Harder tasks require more computing breaks.
Exactly. And it handles those hard multi-step tasks incredibly well.
Did anyone else test it?
Yeah, another user named Kiseki Codes tested it with a video game.
Oh, what game?
They asked the model to build an interactive Mario game. This proved the model handles complete software engineering architectural work.
So it is not just short files.
No, it isn't just writing short snippets of simple code.
It manages the entire project architecture from the ground up. It holds the whole interactive game state in its context.
Yeah, exactly.
DeepSeek Harness makes all this underlying complexity much clearer visually. You see the speed changing dynamically with the task difficulty.
You really do.
Let's pull all these distinct threads together right now. We have the remarkably low cost and the raw speed.
Mm-hmm.
We have practical application inside a clean visual agent harness. Where does this actually fit into your daily life? 2-sec silence.
It really comes down to 4 main practical use cases.
Okay, let's hear them.
First, use it for incredibly fast iteration when you code. You can run a prompt, check it, and change it quickly.
Right, the speed helps there.
Second, use it as a dedicated software coding assistant constantly. It shows clear, undeniable improvements in long coding workflows today.
Okay, what is the third?
Third, use it for high-volume workloads with many API requests. The raw speed helps large token usage tasks finish much faster.
And the fourth.
Fourth, use it for low-latency chatbots that desperately need speed.
But we need to provide a realistic counterweight here today. Blazing speed is not the only metric that truly matters.
Right. For deep reasoning, you need something much heavier still.
Yeah.
For difficult strategic decisions or maximum accuracy, proceed with some caution.
Yeah.
You should still benchmark it against a stronger, slower frontier model.
Will this kind of speed ultimately replace the need for the slower frontier models?
Well, there will always be a profound need for deep strategic thinkers. Some difficult problems require massive compute and very slow deliberation. But extremely fast models will gladly handle 90% of daily grunt work.
No, but it redefines our everyday coding baseline.
The new AI competition isn't about pure benchmark supremacy anymore. It is about who makes the end user wait the absolute least.
Yeah.
You want to strictly minimize waiting while still doing a great job.
The entire paradigm is shifting from pure power to practical velocity.
It really is. You should really try spinning up DeepSeek Harness yourself today.
Yeah, absolutely.
Grab an open router key and plug it right into the dashboard. Watch the complex trajectory of a remarkably fast model directly.
It changes everything.
It completely changes how you fundamentally understand these AI agents.
We will leave you with this calm, lingering thought today. Beat. These newer models are getting unimaginably fast at building complex apps. They can literally build entire functional applications in just 2 minutes. The software generation process is becoming virtually instantaneous for developers now. How long until the human bottleneck becomes the ultimate glaring problem? Simply reviewing that code will soon become the slowest part of the entire workflow. Thank you for joining us on this deep dive.
Catch you next time. OTRO Music.